The objective for today is to solve linear systems by substitution. Yesterday we solved by graphing. Today we are going to solve using the second method, which is substitution. Using substitution, we solve one of the equations for either x or y and substitute it into the first equation and then solve. So our step one is to solve one of the equations for one of its variables. When possible, we solve for a variable that has a coefficient of 1 or negative 1. This is going to make it easier for you and less work. Okay, so you look for the equation that is easiest to solve for x or y. It doesn't matter which one, whichever one you feel would be easier. Step 2 is we substitute, hence the name of this method, the expression from step 1 into the other equation and solve for the other variable. In step 3, we substitute the value from step 2 into the revised equation from step 1. So let's go through an example and do this together. If you look at example 1, we have x equals negative 2y plus 2, and the second equation is 3x plus y equals 16. The first equation is already solved for x, so we don't have to do any extra work. We are going to use the first equation because it's already solved for x, and we're going to substitute the first equation into the second equation for x. So the first equation, x equals negative 2y plus 2, we're going to substitute what x is equal to in for x in the second equation. Okay, so our first equation is already solved for x. We're going to substitute negative 2y plus 2 for x in the second equation. So let's go ahead and do that. I'm going to highlight. We are taking what x is equal to, negative 2x plus 2, and we're going to substitute it in for x into the second equation. So instead of putting an x in there, we are going to put what x is equal to in the first equation. Now you can see we have all the same variable. We can solve for y now because we only have y's in this equation. So we substituted the negative 2y plus 2 in for x. Okay, so you can see instead of an x now, we have what the expression that x is equal to. To solve for y, we need to do the distributive property. And we have negative 6y plus 6 plus y equals 16. We are going to combine our like terms. Negative 6y and y is negative 5y plus 6. And now we're just going to go ahead and solve like we have a... Oh, let me move it up, sorry. We have a two-step equation. Zoom in a little bit. Okay. Subtract 6 from both sides. And we have negative 5y equals 10. We are going to divide each side by negative 5. And we have y equals 2. Okay. Now, now we know what one ordered pair in our solution. We know that y is going to be equal to negative 2. Since the solution to a system is always an ordered pair, we still need to find out what x is going to be. So we know that y is going to be equal to negative 2. We substitute negative 2 in for y in the original equation 1 to find the value of x. So equation 1 was x equals negative 2y plus 2. We're going to substitute the negative 2 in for y, so we can solve for x. I'm going to do it down here. X equals negative 2 times negative 2 plus 2. We have x equals 4 plus 2, and x equals 6. Hang on, guys, sorry. Okay, if you need to pause, go ahead and do that. So now we have our solution. Our x-coordinate is 6, and our y-coordinate is -2. To check your solution, you go ahead and plug it back into the original equations. You can see that having technical difficulties. Okay. Remember to check your solution in each of the original equations. So you're going to take your 6, -2, plug it back into the first equation, into equation 1, make sure it works. Plug it back into equation 2, make sure it works. If it does, then you know you're correct. Okay, let's move on to the next example. Example 2. Solve the linear system, 4x minus 2y equals 14. Take a look, neither equation is solved for x or for y. However, if you look at both equations, equation 1 and equation 2, the second equation, y has a coefficient of 1. That's going to be the easiest equation to solve for either x or y. It doesn't matter which one you solve for, you pick the easier one. So we're going to solve the second equation for y. And I'm just going to write this just as a side note. Solve one equation for x or y. Pick the easiest one. Okay? The second one is the easier one to solve for. We solve for y by subtracting 2x from each side. And we have y equals -2x minus 3. So we're going to take that value for y, or the expression y equals -2x minus 3, and we are going to substitute it into the first equation for our y. Okay, so we're going to take it and substitute it in for y in the first equation. So we're substituting -2x minus 3 for y in equation 1. In equation 1, instead of writing 4x minus 2y, instead of y, we're saying 4x minus 2 times the quantity of -2x minus 3. Again, the word substitution. We're substituting the expression in for y. Okay? Now you can see we have all the same variables in the equation. We're going to do the distributive property. 4x plus 4x plus 6 equals 14. Combine your like terms. We have 8x plus 6 equals 14. And now we're going to solve for x. Subtract 6 from both sides. We have 8x equaling 8. Divide each side by 8. And we have x equals 1. What that means is, in your solution, the ordered pair, your x-coordinate is going to be equal to 1. Now we have to find the y. So what we're going to do is we're going to substitute 1 for x in the revised equation 2 to find the value of y. Equation 2 is y equals -2x minus 3. I'm going to do this off to the side because I always work vertically. So y equals -2x minus 3. We're going to substitute a 1 in for x so that we're finding y. So y equals -2 minus 3. Y equals -5. And we have our solution to the system. We already know that your x value is 1 and your y coordinate is -5. And again, you check by substituting 1, -5 into both equations to make sure it works in both equations. All right, go ahead and pause it. I want you to do checkpoint 1 and 2. And when you're done, come back to find the solution. All right, welcome back. The solution for number 1 is negative 1 comma negative 1. And the solution for number 2 is 3 comma 2. We can go back and check through your work in the first equation, in number 1, I'm sorry. The second equation is already solved for y, so that's going to be what you use to substitute. So we're substituting the 6x plus 5 in for y in the first equation. So we have 5x minus 4 times the quantity of 6x plus 5 equals negative 1. We can go ahead and distribute. We have 5x minus 24x minus 20 equals negative 1. We have, which combine your like terms, negative 19x minus 20 equals negative 1. Add 20 to both sides. Negative 19x equals 19. X is equal to negative 1. We go ahead and substitute that negative 1 back in for y into the second equation, and which gives us the x-coordinate of negative 1. Okay? So we have y equals 6 times negative 1 plus 5. Y equals negative 6 plus 5. Y equals negative 1. Okay? Your solution to number 2, we'll go through the work. We need to solve one of the equations for x or y. I'm looking at the first equation. Doesn't matter which one we choose because we have the coefficient for x is 1, the coefficient for y is 1. So I'm going to solve the first one for y, and we have y equals negative x plus 5. Okay? I'm going to substitute what y is equal to into the second equation for y, and I have 7x minus 9 times the quantity of negative x plus 5 equals 3. 7x plus 9x minus 45 equals 3. Combine like terms. 16x minus 45 equals 3. Add 45 to both sides. I have 16x equals 48. And x is equal to 3. We go ahead and plug that value for x back into the first equation. And we have y equals negative x, or negative 3 plus 5. Y equals 2. Okay, so this video will stay on my webpage. Please use it while you're doing your homework tonight. And you can review it during class again as well. Thank you.